Okay, so this is, we're talking about this picture now. And this is a result of what's called, came from what's called multi-dimensional scaling. We'll look at the software for that in a minute, but let's just talk about this picture. So first of all, although I didn't mention it clearly in the code, one thing that we did in the code was combine all of the movie tags for 1975 into one document. Combine all of the movie tags from 1976 into one document. All of them from 1977 into one document, and so on. Okay? So that was done. Now, what this picture is saying is that 1975 is similar to 1978, similar to 1990, 1982, and so on, as compared to 1975 is not very similar to, for example, 1992. Okay, that's what this picture is saying, basically. So when we say two things are close here, we mean basically that they are similar. Now, how can we possibly say something like that? What does that mean? So we have to talk about it. Now, remember that we had the document term matrix, and it looks something like this. Now, this was for this Reuters stuff, right here, for Reuters. But let's just say for Reuters, we had this document term matrix, and so remember that we had many columns. In fact, I think we had about 1,300 columns. One column for each word. That was in this example that we did a while back, several videos ago. Okay, so each column was a word, and so we said, like, in document 127, able didn't occur, abroad did not occur, and Abu did not occur. And actually, none of these words occurred actually in any of these. But that's what this that's what we had. We have this matrix like this. Now let's suppose, to make it simpler, let's suppose we only had two columns, just the first two columns, just so we can make this look simpler than having 1,300 columns. Okay, so suppose we had that, and here's a picture of that. So we have two documents here. I'm only doing the first two documents, so 127 and 144. So we have 127 and 144. And we have, just suppose we had just these two words. And let's suppose that instead of 0 and 0, it happened to be that this document had the word able, and it also had the word abroad. And that this document had two cases of the word able and two cases of the word abroad, just for example. Now I'm trying to explain what I mean by how documents are similar to each other, or basically the distance between documents. I have to explain that idea. Now suppose, as I said, this is the case. Then we could decide, okay, let's make a picture of this situation, and let's call the first word, or the first column, call it the first variable, or call it x, and call this one the second variable, and call it y. And then we could make a picture. So we'd have the x-axis and the y-axis as normal. Document 127 would have 1 and 1 for x and y, and so we would plot that as 1 and 1, just like that. This would be document 127. And document 144 would have 2 for x and 2 for y, so it would be located here. Okay, so in that case, we could talk about a distance between 127 and 144. And that's not very hard to know what that means. Like, that's just the Pythagorean theorem. So we want to know that distance. And the Pythagorean theorem says that this blue distance is the square root of this one squared plus this one squared. That's the Pythagorean theorem. So it's the square root of so we can easily figure out this length. In fact, it's what? It's just the distance between the x coordinates of these 2 points, so that's just 2 minus 1. And we can easily calculate the distance. This is the distance between the y coordinates of these 2 points. and that's also 1. But in general, the distance is going to be x1 minus x2. So, like if I wanted, anyway, so this is the formula here, okay, which is a simple formula. Okay, so that's the idea. Now we can talk about how far document 127 is to document 144 is in terms of these two variables, in terms of these two words. But if we had 3 variables, then we could say what we could call one more z, and this formula would be x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. And if you're not familiar with this, just go study it a little bit, and I think it'll be clear. And I also talked about it in class on the blackboard. So then we could also, so if we had 3 columns or 3 words or 3 variables, we could also talk about the distance between documents. But in fact, we have 1300, but the formula would just extend. You know, instead of 1, 2, 3 terms, we would have 1300 terms. But still, computer can do that very quickly and simply. So we can then, you know, it's not going to be a 2-dimensional picture anymore, but we can still talk about the distance between 127, document 127, and document 144. And that's what we mean by the distance between documents. Okay, it's this kind of meaning. And you can look this up. If you look up text mining, you'll see lots of discussions about this. So we can talk about the distance between documents. Now, as I said, no, this is not the Reuters documents. This is our movie stuff. And this is all of the review, or what is it, taglines for 1975, and so on. But so we're going to have, how many years do we have here? From 1974 to 2013. So we have about, what is it, about 30 or 40 years or something like that. About 40 years. And so we have like 40 documents. So instead of having 20, like in this case, they had 20 if we went down, we're going to have 40. So we're going to have 40 rows. And we're still going to have some kind of list of all the words in all the documents. This is, by the way, the list of all the words in all the documents. But anyway, we're still going to have a list like that. And then we're going to still say how many times in 1974 did the first word occur, and how many times did the second word occur, and how many times. So we're still going to have basically the same situation that we had here. And so we can talk about the distance between years in the same way, based on these words, or based on this bag of words approach, as we called it. Okay, so we can still talk about the distance between the years. And so it makes sense to talk about the distance between the years. Now, what does this picture mean, though? How do they come up with this picture? It makes sense to talk about distance between years, but where does this picture come from? Well, this is, think about the situation with the Earth, and we have a 3-dimensional object, and then we try and make a map of it. So we have the Earth, there's a globe, a 3-dimensional object, and we try to make a map of it in 2 dimensions. And I'm sure you all know that it doesn't work, right? I mean, things that look big are not as big as they look sometimes, and things that look smaller, right? It distorts things, right? So I guess you know that when you look at this picture, it looks like Greenland is much bigger than the United States, but it's not. It's much smaller than the United States, I guess. But it looks distorted here. So that's the problem of trying to take a 3-dimensional figure and fit it into a 2-dimensional space, or map it to a 2-dimensional space. So it doesn't work perfectly, right? So the same thing with us. So we have, this is not a 3-dimensional thing. This is like a 1300 dimensional thing. And we're trying to fit it into this 2-dimensional space, right? Or so to speak. So it's not going to work perfectly. But what we're trying to do is make it work as well as possible. And that's what multidimensional scaling does. It tries to find the best possible kind of mapping of this. And yeah, so that's what this is. So this is a reduction from that 1300 dimensional situation to this two-dimensional space. But when we do it, what we find is that these things are similar, and whereas this one, for example, and this one are not close. And what that means is that these years are similar, and on the other hand, they're not similar to these or to this, and so on. Okay, now next we will look at the R package for doing this multidimensional scaling.